Uh, Hello everyone, as Christy explained, I'm Antrich. So I'm from India. So we are a French company, but I'm coming from India Labs, Orange India Labs. So FIWARE. So how many of you, you saw the pamphlets earlier, so you got a chance to see on internet what FIWARE is, and what did you find out? If you have seen, anyone? No? How many of you think that's a proprietary software? Okay, it's not. So, FIWARE is a middleware platform promoted by European Union for the development of global deployment of internet application for the future. FIWARE tries to be completely open, public, and free architecture, as well as set up application that allows developers, service provider, companies, and other organizations to develop products that meet their needs. So the motto of FIWARE is to build open and sustainable ecosystem around public, royalty-free, and implementation-driven software platform that will ease the development of new smart application in multiple sectors. So the motto of the FIWARE is, to be always royalty-free to use, and it's always open source. So FIWARE is actually a system, it's a whole full software stack which you can use to build your smart application for mainly for IoT and smart devices and so on. So you will see the stack. I'll show you in a future slide. So why we choose FIWARE in first place? I mean, why would you choose FIWARE? So it's a full stack of generic, open, and reusable components which are seamlessly connected to each other. So you have the full stack capability starting from the collecting the data from the sensor to, let's say, for big data analytics, for artificial intelligence, machine learning. So everything is quite integrated with the whole stack you have access to. It's royalty free, so you don't have to use it. You don't have to pay any royalty, and it's based on open standards. So we follow open standards like GSMA, we follow ETSI, so we want to be standardized. We have large community of developers now, so a lot of big community, so you get answers to your questions easily. No vendor lock-in. So now, you saw in the presentations from Prof. Islam and also from Dr. Selva that the cloud services have a problem with vendor lock-in. So we promote no vendor lock-in. So because you make your software in a standardization data models, so you will never have the problem of vendor lock-in. So you don't like the vendor, you change the vendor. As well as it's modular, it's scalable, and it's continuously tested. So all the FIWARE applications that we will see today, there are performance tests available online that you can refer to, and you can see how we continuously test this performance to be sure that it's market ready. And can plug to legacy systems. So, okay, so this is, we might have some legacy system before FIWARE, or using like traditional technologies to deal with things. So FIWARE provides you this option that you can easily plug your legacy system to FIWARE. Now let me take you to the stack. This is the stack. So here on the you can see deployment of IoT networks, cameras, and robots. So you see there's a camera here. So we have an enabler called Currento. Now Currento is the enabler that you can use. It's based on WebRTC. You can use it for your augmented reality. You can use it for communication, for video chats, for multi-endpoint EDA chats, or like that. So you can easily use it and configure it. So on the bottom, you can see that you might be having the security surveillance cameras connected to this enabler, as well as you could have alternative IoT platforms. They are like alternative IoT platform like Eclipse M2M, so one M2M. So you could connect that also with FIWARE. If you go right, Then we could have the different kind of sensors. Okay. Now what do you think is a smart object? So you see smartphone, you see smart dad, smart city, smart dad. What do you think is a smart object from your definition? Anyone? Smart object. Any smart object. What makes an object smart? Yeah.
It can respond to environment.
Can respond to environment. Anyone else? It's close. Okay, so we can say that. Can we say that the smart object is something which can understand about its surrounding and can understand its state of itself? For example, I don't have a pen right now, but let's say I have this. Let's say it's a pen. So a pen has a level of ink. Okay, a pen has what it has. Its color and all these things. Temperature outside, temperature inside, humidity, and those. So if it's not aware of all these things, it's like a normal pen. But if it's as soon as it's aware of itself and its surrounding, it becomes smart. So you can say that anything can be defined in form of entities and attributes. For instance, a pen can be defined as pen as an entity, and attributes could be like its ink level, its temperature, and like that. So you can define anything as entity and attributes. So when the sensors are, let's say, connected, you could have one sensor in this room right now, which could be measuring the temperature and humidity, luminosity, a sensor here, and it could record this and it could send it to some central place, which we call as Orient Context Broker. So you can see on the bottom here you have some sensor, and there is an IoT agent here. Now, from what I understand, a lot of you are not coming from IoT backgrounds. Just to tell you something about this IoT agent, is that all these sensors, okay, and all these gateways, because the sensors they connect to gateway, and gateway is the one which is going to a central server, which we call it Orient Context Broker in case of FIWARE. So these sensors, they talk in their own protocols, okay, like MQTT. Anyone heard about MQTT? It's a protocol for communication. So because these sensors, they have a limited battery, they have limited battery, they have limited connectivity and like that. So we have to save everything, the bandwidth and everything. So they cannot have the whole TCP stack on top of them, because it will your sensor will become more expensive if you add more such kind of stacks. So what they do is they use some other protocols, like CoAP, MQTT, or even the physical layer protocols you must have heard about, LoRa, NB-IoT. So on the bottom, you can see these sensors, they will talk among each other using these protocols. But we have IoT agents to translate these protocols to what we call as NGSI. So you have native protocols, and then everything, the whole flow is in NGSI. So from there, from this point up, everything is in NGSI. This whole everything is in NGSI, so that you have one single protocol across the whole system. And if I move further right, you have CRM and social network. So maybe you would want a utility like that you have a Twitter and you say, you tweet your TV at home, please shut down. So you want something like that. So you can do that. You can write a system adapter to take this from the Twitter and then perform this kind of operation. Or you can get the status of this room using Twitter. Why can't you? Then smart parking, air quality, public and waste management. So, are there any kind of such kind of smart services that you see in Philippines? Smart parking, air quality, public transport. Anybody would like to tell about this? Any service that you must have seen, like smart street light or like that? No? Okay, not that you're aware of, maybe. So, so you have air quality sensors. You know, they are there in every country. It's where people are getting very sensitive about air quality. They want to know what's the quality of air they're getting. So these are sensors that, you know, usually the government, that are investing on, you know, putting these sensors. That public transport and waste management. So these are the things which, you know, automatic waste collection system, for instance. Like people want. So when the truck moves across the city, so we're talking about smart cities today on FIWARE. So when the trucks moves around the city, it needs to track that which place to go to collect. You know, maybe it's not efficient to go one place which doesn't have the good waste level. You know, once it fills up, it can go for the collection. So if you have the right state of the waste bin, what you can do is that you can devise an algorithm that can you know, you can monitor, and you can tell your waste management system that this is the route that you need to take, like that. So, you know, these are kind of few of the advantages you get when you put sensors and you make your things more smart. Now, if you move further up, as I told you, that you can express anything in form of entities and attributes. So you see, you can define a street in form of location, traffic, and pollution. Okay? You can define a parking space in location and number of slots. So if there's a parking space, let's say you have a parking space nearby, and if you have a smart parking system, you have a car, you drive, and then you see whether I get a parking space. Does it happen in Philippines? You don't get a parking space? No? It happens very often. Okay, so just imagine that you are stuck in traffic in Philippines, and then you go and you don't have the parking, so you cannot go. So if you have a smart parking system, you can know that if there is a slot available, maybe you can book the slot if there is a feature in the software, and then you park the car. Good to go. And then you have waste bin. So waste bin I talked about. So waste bin can have like location, capacity, level, and threshold. A shared car. So do we have shared car system in here? Do you share cars? So do we have an app for sharing your car? Yeah, so you know, this kind of system you can also use, and you can use FIWARE to make something of your own very easily, which is what we learned today. Then we have citizen claims. So of course you can also keep citizen data. So this is the context broker. Now context broker is an enabler. What is an enabler? It's just a piece of software. Okay, it's a piece of software which you can deploy on any virtual machine, or you can deploy as a service. Now if you move further, so this context broker only stores the current state of an object, the current state, the current location of the bus, the current state of the waste bin, the current status of the shared car, and so on. What if you want historical states? What if you want to apply some analytics on top of it? What if you want to make your services more efficient by applying analytics and predictive analytics on top of it? So for that, we have more enablers. Like you can use the, if somebody's from the Hadoop backgrounds, and you can use easily Flunk, Spark, and Hadoop. And there are some enablers called STH Comet that can help you with analytics. So you can get some aggregation, you can get some time series, you can know what was the time series means, like you can get the average for the day every day, or you can have average for an hour every day, something like that. You can apply that aggregation in time series also. Something you can get, it's a kind of analytics. Then you can also have aggregation, you can also do predictive analytics. If you move further up, you see there you can achieve big data algorithms, AI algorithms, and if you move here, then comes the next part, the visualization. You have the data now you need to visualize. So FIWARE provides you this. FIWARE provides you a Wirecard mashup, GIS, and Knowledge BI. So these are a few of the enablers that you can use to create your UI, okay, with as less programming as you can. So it's like you have the whole stack, you have the sensors, everything, and you can build everything very fast. If you move towards the right, you see the open data portal and data marketplace. So you have the data now, and maybe you want to sell it. You want to, the data is a fuel. The fuel of the last century was, what was it? Petroleum, right? The fuel of this century is the data, as many of us talk about it. So if you want to sell your data, then there's data marketplace. Then CCAN. But CCAN is a portal for if you're a citizen, you want access to the data from the government. So CCAN is a de facto standard for that nowadays. Like the biggest CCAN I know is EuropeanDataPortal.org. Let me open it for you. Now this big database, CCAN, has data, all the relevant data that a citizen needs from the whole Europe, European Union, I mean. So how it works is that CCAN has, now you cannot keep the data at one place, right? It's difficult to keep the data at one place, and especially if one country wants to keep the data in their own country. So what they do is that CCAN has a feature called harvesting. So you can keep the data, the France can keep the data in their country, and then the European data portal can harvest the data from there so that you can have the links up to the bottom, up to the top. So you can have a city-based CCAN, then a state-based CCAN, and then go further, like this. So CCAN is a kind of a standard now, like UK is using it, many other countries are using it actually, to store the data and to share the data with students. So what kind of data do we have? You have data for agriculture, energy, what are the needed regions and offices and all that, international issues, justice and health and all that. So you can store the data in CCAN. What else do we have? So here you can see on the, if I go further right, there is Key Rock and Velma and API management. So you have the whole stack. We didn't talk about security now. So this will provide you the authentication and authorization required for your whole stack. So you could apply QRock and Vilma to add these kind of features to your software that you'll develop for your smart city. And then there is a TM Forum Business API. So TM Forum, if you want, if you have, let's say, a sensor provider, which is a private firm, then there's a government. If you want to like share your revenue, something like that you want, that you can do using TM Forum Business APIs. Before I move further, I would like to take some questions if you are able to understand this and if you have some questions so far. Any questions until now? We need to do the karaoke night again, I think. Okay, so you see on your, now the context broker, we'll talk a lot about context broker today because there are so many neighbors and we cannot cover all of them. So we would be only mainly focusing on the context broker. So context broker, as I told you, can store the current state of a smart object. So there could be two things. One is a context producer, and another one is context consumer. What is a context producer? Your sensors are your context producers who are going to produce the data. Then what are the context consumers? They are going to consume your context. Like if you have a mobile app, you would like to see what's going on, you know. Then there is a subscription mechanism as well. Now, if you would like to, let's say, subscribe the temperature of this room, okay? For instance, you make a smart AC system here, okay? You feel cold, you don't want, you just want your AC to, turn off automatically. So how you can do that? You can do that by creating a subscription to the temperature in this room, and as soon as there is a change, you will be notified, and you can take action accordingly whether you need to turn off the AC or not. Okay? So as I told you that you can express anything in form of entities and attributes, any smart objects. So here are some examples. You can express a shop in form of location, business name, franchising offerings. You can express a bus in form of location, number of passengers, drivers, license plate, citizen in form of birthday, preferences, location, and to-do list. So you can see that some of these attributes, now when I say attributes, I'm talking about location, business name, and franchising offering, which are associated with the entity, which is shop. So all these attributes, some of the attributes are actually static. Like location of shop is not going to change, shop is not going anywhere. While location of bus is dynamic, it can move. So you can express both dynamic as well as static attribute. So this is a case for smart cities. Similarly, you can do it for smart agri. You could have a crop, humidity, leaf area, age, tractor with location, speed, and direction, drone like this. For smart industry, you could have a gas tank, you could have a tanker, you could have a station. The tanker could have driver, location, max volume, current level, these kind of attributes. So you can express it very easily. You can connect your sensor very easily, and then you can connect with FIWARE. So what benefit you get while making an application using FIWARE? Since you use same standard, okay, across the system. So what you're seeing here is open source. So you don't have to pay any amount for using it. But the benefit you get is that you have one city which has developed an application. Okay, there is another city which has developed another application. So you can easily port one city to another city very easily because you're just based on open standard that you follow. We'll talk about some data models in the future sessions today. Now let's come back to some use cases that have been built using FIWARE technologies. So let's talk about InSilo. So InSilo is, as you can see on the right, you can see there's an interface also of InSilo. So what was the problem? The problem statement was that there were some farmers and they had a lot of cattle feed, if you have to feed your cattle. So that cattle feed was like, somebody has to manually go up and to check what is the current level of the feed. It was like time taking and, sometimes it's really difficult, it's manual. So what they did is they developed a pre-scanning mechanism. So they deployed a camera and a 3D scanning algorithm to monitor the current level of the feed so that it can be replenished automatically. So then it was connected to the delivery system. So as soon as there was a less feed, it was automatically a notification was sent to the van to add more feed. So this system was a solar project. This is a solar project, so it's very easy to deploy. If you have some bunch of if you just have a silo, you just plug and play. Just uses solar energy. That a device. So nowadays, people are getting also very sensitive about the water in some countries specifically. So they would like to know what is the health of water they're getting in the homes. So what they did is, so how many of us know about LoRa or LTE networks? Okay, so these are like, the traditional you have is your cellular network and all that, or so they have like if you use this kind of LoRa or LTE network, you can have a range for like 20 kilometers. So you have just one antenna, and you can make your own sensor network, which will work for very large distances. So they developed a LoRa network, local LoRa network, at some let's say frequency which is not resolved because you have to be very sensitive about frequency. So free frequency you have to use. So they use that and they developed technology and they deployed some sensors in their home. so that people can see what's the status of the water they are drinking, okay? The level of impurities in water and so on. Then also about noise pollution. So in one of the city, people just wanted to know what is the noise they're getting so that they could reroute the traffic if required, because traffic creates also a lot of noise pollution. It's a matter of concern for a lot of people, and it creates a lot of problems for health of a lot of people. So that's why they developed this tool. So it has a sensor called FIWARE that you can deploy on various location, and then you can monitor the level of noise in decibels or other units, and you can know that this place is very noisy, and maybe you could reroute the traffic. You can remove something in order to make it less noisy. So on the right, you can always see that there is a dashboard. There's a dashboard here. So how you can see a different part of the map. The Cardioid. So Cardioid is an application they developed for the fleet management. So there's a car, you have drivers, and sometimes they go to sleep. So you are really so what they did is they developed a smart variable system. So you can just wear that variable, and you can as soon as someone is trying to sleep, or maybe he's not having a good health state, maybe there's a problem with heartbeat or something like that, immediate notification go to central authority so that they can take immediate action about it. Okay. Then smart cattle bus sensor wave. So if you, like for the villages, in the farms, they have like cattle. So what they did is they developed some sensor that you can tag the cow in their ears. You can just tag it, and then you can monitor where the cow is going. You can monitor the health of the cow, and so on, so that the farmer can know in advance, like if something is wrong, they can, if there is, let's say, weather not good, then they can monitor the cow and they can take care of that. I'll show you a small demonstration application. So I want to tell you that this is an application which I developed, which only took me like 2.5 months to develop that application. So what I want to show you is that how easy it is to develop application using FIWARE. So this is an application which I've collected data from sensors mainly from India, from France, from China. Okay, so it has data for weather. So you can see the data, which is I'm using Google Maps here. So all the data is stored in FIWARE system, and what you see here is weather of that particular location. Now, also, how I express the weather information is very standard, in a very standard format. So you should always take care, in case of FIWARE, that you should use your open data model, so that if you develop a weather application and another party develop another application, it should be synchronized with each other. So these weather models, or these kind of models, they're well defined, they're available, they're public, so you should refer it while making such kind of application. So you can see the data of weather, what is the weather condition in particular area, and if I move here, you can see the air quality in some parts of India. You can see PM 2.5 level, PM 10 level, and so on. If I move further here, let's go. Then there is information of live train. Where is the location of the train? You can track that. Then if you move to France, so here you can see the live location of bus stop in Rennes. Rennes is one of the city in France. You can see the bus stops. Where are the bus stops? you can see the live location of buses. So here you see that there are there are three color buses. One is orange, one is black, and one is painted orange and black. So if I, let's say, zoom in further, you can see there are a lot of, this is the orange bus. So, but if I go for orange and black, you see there are a lot of orange and black buses located at one single place. So let's see what is there. So these are the buses which are not moving. So you can see that these buses are it's showing the state of the bus. So the orange and black buses are the ones which are not in service right now. So you can see they're standing in the bus yard, as you can see on Google Maps. And if I move further, there is bicycle service. So you can see, okay, so do we have a smart bike system in Philippines? You know, do you like to take your bike and, you know, by bike I mean bicycle? No? Okay. So here in France, you have a system that you can, you get one Navigo card that works everywhere for any kind of transport system. So like you can use that Navigo card for using your metro, you can use that card for bus and everything. So it's just one single card. But you can also use that card to pull a bicycle. So there are bicycle stands there. You can pull your bicycle, okay? The weather is very nice there, so you can easily drive. You just take the cycle out, and then you find the next station where you want to go, and you park your bicycle there. That's it, simple. So by this, what I'm trying to show you is that you can monitor whether there are enough stands available, enough cycles available, and these kind of statistics are available. Okay, you can get access to that thanks to the sensors deployed on those stands. And that's it. That's what I wanted to show you in this demo. So you can, of course, plug in, like for one of the city, you'll be surprised, in India, we had a problem that people were stealing transformers. Yeah, and I think they were just selling them. So this problem statement came to us from our business team, so we developed a solution in order for them to track the transport, to track the system, people trying to thief. So I think that's it for this subject. So before I move to another subject, I would like, I can take some questions.
Sensor in that transformer or somewhere else?
Okay, so what we did is that we provided two kind of solutions to the customer. So one was there was some transformers which were old. Okay, so what we did is for the old transformers we provide over-the-top solution. So you could plug a device on top of transformer, and the newer transformers. So for those. We talked with the transformer company to automatically provide in-the-box support for this kind of sensor.
So where it goes automatically?
Yes, we will know. So it has a battery also, so we will know where it goes. You can track it. So you know that, yeah, you're right. So it was too small use case even for us, that we just were tracking the transformer. So we also added some more features to transformer, like the transformer has oil. And transformer has some more attributes, like, you know, it's voltage, the power is going in, power is going out. So we added more sensor on it, so that, you know, it would the system that we're building can have more features than, and temperature of transformer and all that, so that we can this also really helped them to preserve the transformer, because there were a lot of transformer crashes. So now if we monitor the oil level and temperature of transformer, we can inform them in advance that there is some problem, you need to take care. And yes. Any more questions? Please don't be shy. Yeah. Sorry? CCAN. Okay, let's say when do you use a CCAN? So CCAN, for instance, you have this bus, okay? You want to make an application that has IoT data, and then you want to create a data set on CCAN that stores the route of the bus. where the bus is going every day. So for that, what you can do is that you can plug it to CCAN, and it will make the whole series that, okay, at this point, at this time it was here, this time it was here. So CCAN is mainly used for putting the complete historical, having some data set. But CCAN is not limited to just sensors. So CCAN, if you want to just upload some CSV or TXT and all that data sets, that you can also use to CCAN for. This uses Orion Context Broker. Just to tell you about some of the other enablers that we have here. So there is a we talked about Orion Context Broker, which is manages for the context information. So it only stores the current state of the object, as I told you. There is IDAS IoT agent. So as I told you that the IoT agents, they talk in their traditional protocols to translate that into NGSI. Then we have Currento media player, Currento server, which is WebRTC based for transcoding, for computer vision, augmented reality, and so on. CPS enabler, it's provide edge level intelligence. Okay, sometimes you need a edge level intelligence. Let's say you're making a smart agriculture project. Okay, in a smart agriculture project, what do you want? You want the irrigation to be done automatically. You want the fertigation to be done automatically. For that, you don't need to, let's say, go to the cloud. You don't have to report to the cloud. The cloud will take action. What you need is edge level computing. Your the edge, I mean your system which is deployed on the field should be able to take immediate action about it. So you can have that edge level intelligence using CPS enabler. CCAN, we talked about it. So it's a comprehensive knowledge archive network by definition, and it's open source also. Then Cosmos Big Data. So you have collected all this data. So you can have multiple streams for historical data. So you can send the data to CCAN. At the same time, you can send the data to Hadoop. So there's a Cosmos Big Data enabler which is based on Hadoop. Sorry if I'm blocking the view. So it's based on Hadoop. So you can plug in to historical analysis for both CCAN and Hadoop at the same time. And you can apply some kind of map reduce or whatever you use. Anybody who use big data or Hadoop here? You? Okay. So it's actually for, you can do again aggregation. Like if you have a lot of data in terabytes or like say even more than that, exabytes or like that, and you can store the data here, and then you can apply the queries, and you will have the data access very fast. You can have a fast data access. Then Cygnus is the enabler which you can configure. It's actually just like a messenger. Okay, so if you want your Orion Context Broker to store the historical information in both CCAN and Hadoop at the same time, then you need to use Cygnus for that. It will act as a pipe, and it can transfer the data to both of the enablers. Now we'll go to any questions. Feel free to ask me a question anytime. Okay, you can stop me. We have limited participants, so you can ask me if you have any question anytime. Then we'll talk about the next Orion Context Broker in little detail now. Okay. So we'll talk about the context management in FIWARE, Orion Context Broker, how you can create data, how can so this create data or pull data, how you can push data, how you can perform batch operation. So as I told you, there is a one-to-many relationship between entity and attributes. So any entity have mandatory attributes actually, which we don't call as attributes. So it should have an ID. Every entity should have an ID, okay, and a unique ID. and a type of that. For instance, if it's room 1, for instance, it's a Philippine room, or I don't know name of this room, what is it? So let's say it's a Philippine room, let's call it Philippine room, so it could be the ID, and the type would be room, okay? So these two things are fixed, okay? And the other ones, which are the attributes, so it can have some attribute as well, like temperature, humidity, pressure, like that. So 1:n relationship between entity and attributes. So once you install your context broker, so as I told you, just a piece of software you can easily install. Once you install your context broker, you'll have, you need to verify if it's successfully installed, okay? So what you can do is you can just call /version. You will get the version. This is what we do if you want to check if it's up and running, okay? Because you need to check if your service is up and running. Okay, so for those who are not aware of REST API, okay, how many of us know what API? What API is? Web application or web. You know about web API, okay? Anyone else? Web API in general, web service. Okay, great. So here you have some web services, okay? So you could have 4 possibilities, okay? For instance, let's talk about context, okay? Which is something which we all understand. The context of this room, which is the current state, is called as the context. So you can have 4 possibilities. You can have either try to get the context, you can try to update the context, okay? You can try to delete the context, or you can try to, which one is remaining? To create the context, okay? So if you want to create this room in FIWARE, which is context broker we are talking about, you will use post, okay? Let's remember it this way. So post is for creation, okay? If you want to get the current state, it's get, okay? If you want to delete this room from context broker, you use delete verb, okay? But this is all defined as, these are not specific to FIWARE. These are all defined as HTTP in HTTP protocol, okay? These are the HTTP verbs. Then what is remaining? So I think there is one which is not remaining, which is remaining is this put, which is if you want to update the context. I mean, let's say you have a sensor, so once it creates the room, it needs to continuously every 15 minutes, it needs to take a fresh observation on the room and to report it. Like current it's 20 degrees, and after some time it's 25 degrees, so it needs to report it after 15 minutes. It's up to you. It's up to you how you define that strategy. Like you want it to be updated as real time, so you can have it like, like push kind of notification, or you can do it every 15 minutes, depending on the criticality of your application. With just room temperature, it doesn't matter. If it's a flight, it's going to, if you don't do anything about it, it might just fall, so you have to be very real time about it. So this is an example for the creation of entity, okay? Simple, very simple example. Car, we all understand. So it's a car, so you can see what we did is, there's a URL on the top, CB host. Host means the IP of the context broker, okay? The IP of the context broker, the port, okay, the port. So by default, the context broker, it listens to 1026. It's the default port for context broker. But of course, you can change it, okay? And then /v2/entities. This is the URL on the top that you see. And what we are trying to do, we are doing a post. Post means creation, okay? So we create it. So what we do, what we define in the body now. What else did we define? We define content type as application JSON, okay? Because the body that is there associated with this request has JSON content, okay? Everybody knows about JSON? Okay. So you see this is the JSON content here. And what I've defined, as I told you, the ID and type are mandatory. Okay, so ID is car 1. Okay, the car 1 or whatever you want to call it, it should be unique. Your car, you can put your name and the car. But what you need to be sure about, it should be unique in the context broker that you installed. Okay. Then type is car. Okay. What else do we have? Speed. So car does have speed, right? So you can put the speed as like 98. For instance, you just create it with any speed. You can create it with speed 0, no problem. Just creation. Then as for HTTP protocols, you have response codes. Okay, some response codes. So you put the request, you should get some response. Okay, but there are like successful response code. There are failure response code. So when you do a post, if you get 201 created, that means it's successfully created in the system. Very good for us, right? So when we do a post, if you get 201 created, it's created. Or if you get any other code, then they might be in error. Okay, you did a post. So now what you want to do is that you want to update that value. So because it's your sensor, right? You're building everything from the scratch now. So it's your sensor, it's your source code. So if you want to, you would need to update the value of the speed time to time. Okay? If the speed increases, you have to update the server. If the speed decreases, you have to update the server. Okay? So what you do is you put a put request, and what you do is /cars/attr/speed. So you can see the URL. Now content application JSON again. And now what I did is the same entity. You can see what is the name of entity. You can see put cb host 1026/v2/entities and /car1. That is the name of your entity. Name of your entity, okay? And what you're doing is that you're setting the speed from 90 to 110 because the guy speed up, you know? So the guy speeded up, so you need to update that. And the success code is 204 if it's successful. Then you can do a get, okay? So if somebody is monitoring the speed, let's say you make an application for fleet management, you know. You have like Uber-like application, for instance. You want to monitor if your driver is moving too fast. You know, you need to get a report of that. So for that, you can make this application. What you can do is that you can do a get to your server on the cloud, and what you can know about what is the current speed, and you can take an action and call him, please drive slowly now. So things like that you can implement. And then what else is there? You can do a put again. So now that was text JSON. If you want to, let's say, keep it short, then if you see here, it ends with speed/speed. And if I move here, you can also do /speed/value. So what it does is that you can use text plain. So you can have just one liner body if you want to keep your body small, because the bandwidth is limited. So if you want, let's say, to consume less battery and like that, so you need to have small payload, okay? As small payload as possible. So you can achieve that by using text plain. So you can set it to 115 now. You can see when the speed is reduced. Similarly, you can do a get like this. Now, I talked a lot about room. So here is an example that, now context broker is heterogeneous, which means it can store the information from of multiple type of entities. So it doesn't have to be one type of entity, it could be multiple type of entities. So you can store the car, you can store the room in the same context broker if you want. Okay? So you can see there is temperature, there is pressure, so type is float, a value is 24. So you can define the type also. It has to be float or it has to be integer, that you can also define. So we created a room one here, like we created a car, and you can see it's 201 created. You get in response. It's success code for post. If I move further, what I do is that I'm trying to just get the attributes, and let's move further. okay, here. Now similarly, I create another room 2, okay? As room 1, I create another room 2 in the system with different temperature and different pressure. Let's say there are 2 rooms here, and you put 2 kind of sensors in different rooms, okay? Now if I move, if I want to apply, what if I want to apply some queries now, okay? Now there is one room, this is room 1, and there is another room 2, maybe meeting room here. And you want to find the room which has temperature greater than 27. So you can easily query by doing a get, okay? Get is for getting. And then you can apply the query Q equal to temperature greater than 27. So you'll find all the room which have temperature greater than 27. Okay? You want all the rooms where the pressure is between 715 to 725 bars. You can get it like this, you know, dot dot. Then I talked about that we have a feature called subscription mechanism. Now let's say there is a fire alarm here, okay? You develop a sensor for a fire alarm, you install a fire alarm here. And you want your system to be, your mobile to get a notification if there is a fire alarm hit, okay? So what you do is that you subscribe to that particular attribute, okay? Now there is a system here, what we call as the downstream, okay? Which is reporting that there is a fire, okay? Then you can create, because you know HTTP is only one side protocol, it's not like two side, you know. It cannot, the server usually cannot push notification directly to you, to a client. It's usually only one side. So you can create notification, and notification, what it will happen is that when there is a state change in the fire alarm, you will get the notification in your phone. Okay, you can easily make an application, and you will have that. And how to do that is like this. You create a subscription. Okay, so instead of v2/entities, which we did in last slides, we do post on v2/subscriptions. So you can see here is entities, ID room, type room, so ID room 1, type room. So what I want to do is, I want to monitor room 1, okay? I want to know what's going on in room 1, okay? So yeah, I cannot just see anything. It depends on what programming you have done, okay? You not go as magic, you have to do some little bit programming as well. And if I move down, you have the condition ATTRS temperature. So which means if there is a change in temperature attribute, you'll be notified, okay? Then there is another section here, notification, okay? So if there is a change, who do I tell you? Who do I tell? The system is asking, or in context broker is asking that if there is a notification, if there is a change in attribute, who do I tell? So that is this URL you can see, HTTP host port /publish, ATTRS temperature. So you can, as soon as there is a change in temperature, the temperature would be in a I'll show you format in the next slide. There would be notification sent on this server, HTTP host port and publish. So you can just start a server and you can listen to a port, okay? Simple server, you know, you can, in most of the programming language like Python or any other programming language, you can easily spawn a server, okay? You spawn and you listen to a port. So you can just spawn a server and spin a server, and when this will happen, it will just send notification to your server. And what do you get? So what if there is temperature drop between 25 to 19? You get this on your server. You get this data, ID, type, and temperature. So you get temperature has been reduced. So you get this notification, so you can know that, okay, temperature has changed. Or in case if there is a fire alarm, the state is changed. Okay, so you can always list the subscription that you have every time. Okay, before I think I'll show you the batch while I'll show you the demonstration. So, okay, this ends my this particular session for Orion Context Broker Basics. So I can take some question. Do we have any question? Did you try to make any smart application at your home, for your room, for your automating your home or something like that? Yeah?
I'm not sure if this is possible for school projects.
Sorry, the question is if it's possible to
Or
use.
if you can recommend this for school projects, or yeah, that's it.
It's open source, so you can use it for your research project. You can use it for your commercial project. You can use it for any kind of project. So, is it okay for this? Any more questions? Yeah.
Maybe I wasn't able to follow your input about the API, the post API.
API,
Post and put.
post and put. Okay.
Okay, I'm concerned about the security aspect of it. Because in my experience, API for posting and putting should include tokens. I observed that you don't use tokens in this case.
Okay, understand your question. So actually here, what we used is Orion Context Broker only. Okay. When I was showing you the software stack, okay, we have some enabler called KeyRock, okay, that you can, they work like a reverse proxy, okay. So once you put KeyRock on top of Context Broker, you'll get all the options of tokens and authentication, authorization that you require. So it's just a matter of configuration. You can achieve that. So this is just for the demo purposes. I kept it simple. Otherwise, you can add authentication as well.